Hi, everyone. My name is Shweta, and to introduce our project, we worked to answer the question, can a site be determined to find Martian meteorites in the Antarctic? So to give you some background about our research, we collected our data from ANSMET, or the Antarctic Search for Meteorites. And ANSMET is a US-funded project to collect meteorites from Antarctica specifically, and they work in collaboration with NASA, the Smithsonian Institution, and the National Science Foundation. So samples are collected from the Transantarctic Mountains, and then they're returned to NASA's Johnson Space Center to be curated, and eventually the samples are lent out to scientific researchers. So our group specifically focused on meteorites from Mars, and these Martian meteorites are categorized as shergotite, nacolite, and SNC orthopyroxenite.
Hello, my name is Fernanda Oleas, and I'll be talking about the details and approach our team took for our research. By using the ANSMET database and sources such as the Meteoritical Bulletin database, the 15 cataloged Martian meteorites were divided within 7 sites throughout the Antarctic. The Miller Range icefield and Larkman icefield each had 4 Martian meteorites. Those sites had the most meteorites found. If we take the data all combined, there's not sufficient data to determine whether Martian meteorites can be found on a designated site. For this reason, we drew the observation of how when those billion-year-old meteorites land on the Antarctic, they undergo a snow accumulation that leads to the meteorites stuck into blue ice. With the help of gusty winds, the snow covering the blue ice is moved, leaving the Martian meteorites visible to humans. Ultimately, with blue ice at the sites, it might be possible to find an abundance of Martian meteorites. Thank you.
Hi, I'm Valkyrie, and I'd like to go over the results of our research. There were 15 individual meteorites that we looked at for data in Antarctica. The first one we looked at was the ALH meteorites located in the Allen Hills, each of which were classified as shergotites and orthopyroxenes, and we found that they were all clustered within a 100-kilometer span of each other. The EET meteorite was close, southeast of Allen Hills, weighing in at the heaviest weight of over 7,000 grams. We observed the LEW meteorite next, closest to the Lewis Glacier and cliff. Its latitude and longitudes were very close to the QUE meteorites, and both were classified as shergotites. Staying on the same map, we moved south towards the MIL meteorites all along the Small Miller Mountain Range. There were 4 samples here, all of which were nacolites and much heavier than shergotites when compared to LEW and QUE. The LAR meteorites are next, located near Shackleton Glacier, which flows from the East Antarctic Sheet to the Transantarctic Mountains and down to the Ross Ice Shelf. There were also 4 samples there, all shergotites, but only one was found on the Larkman icefield, which is the material on the surface of a glacier. RBT meteorites compare with the LAR meteorites in both their location and classification.
Hello, my name is Bethel, and I'll be concluding our research. Ultimately, a site cannot be determined to find Martian meteorites in the Antarctic because data is limited and uncorrelated. I say this because there were only 15 meteorites found over 44 years, 7 locations, and hundreds of kilometers. Therefore, with more data, future researchers will be better equipped to further explore this research question. However, as Dr. Fries, a cosmic dust curator, stated, the size of the Earth versus the galaxy makes it almost impossible for a specific meteorite to land in the same location every time. Therefore, there is no correlation between the two.
Hi, my name is Sofia, and I'm going to be going over the highlights. Some of the best features of the SEAS program was hearing from all of the NASA Ares speakers and the SEAS speakers and hearing about their different jobs, career paths, and experiences. It was very helpful working with our mentors and learning from them, and it was great to work with our groups on our project. Some of the challenges were analyzing the data and forming a conclusion based on the limited evidence we were given. In the SEAS intern program, we were given the opportunity to learn about successful people's journeys and gain confidence about our future educational, career, and social goals. And we would like to thank the Texas Space Grant Consortium, the NASA Ares speakers, and the SEAS Speaker Series contributors, Suzanne Foxworth, Kelly Pando, Margaret Baggio, and Selena Miller for all their hard work to make this program successful. We can now take all your questions.